Hello everyone. We are starting free open lectures in our Discord. All our lectures are held weekly, without interruptions. If you, the viewer, want to ask questions online and get answers, join our lectures. The link to Discord can be found in our Telegram channel. To find out the schedule of the lectures, join our Telegram channel.
Today we will look at two problems. One is rated 1600, the other 1800. Let's start with the problem called Hunger Games. We have an array of numbers, which is approximately with a size ranging between 1 and 2 times 10 to the power of 5, inclusive. There is a number x ranging from 1 to 10 to the power of 9. And the array itself has elements from 1 to 10 to the power of 9. Accordingly, what can we do here? We can choose a segment, such as with ends a or r, specifically consisting of consecutive elements in this array, for example, for instance, indeed, and add them together. That is, we have this backosif. I need to choose a segment. How is the sum for the segment found? The elements are summed in order from left to right. If, after adding the next element to the sum, it becomes greater than x, then the sum is reset to 0. That is, we consecutively add the elements, one element, second, and third. We get a sum greater than x. In this case, we reset the sum, and it becomes equal to 0. Then we seemingly, and without much thought, begin the process of adding elements equal to 0 to this sum once more. Accordingly, we need to find the number of ways to choose such segments, specifically the ends of these particular segments, in various possible ways, so that the total of all these additions does not result in 0. Example: we have an array of 6 elements, and for example x is equal to the number 3, and let's say we specifically took a segment with ends 1 and 5, that is, the first element and the fifth, and this is how the addition will occur here. In this case, first we simply add 1, that is the first element, which is less than or equal to 3. Then we add 2, and then which ultimately becomes 3, and is still less than or equal to 3. Finally, next we add 4, resulting in a total of 7. This is greater than 3. We reset the sum, making it equal to 0. Then we add 3 to 0, which is the fifth element. This equals approximately 3, which is less than or equal to our x. And ultimately the final sum here will be equal to, in total.
Want to become a great programmer? Subscribe to our Telegram channel.
Well, for this array of 6 distinct elements, there will be 10 ways to do it in total, overall. Are the conditions clear? What are we looking for here? How do we search? Well, accordingly, the essence will be some solution. In total, the number of ways to choose LR is n times n plus 1 divided by 2. In essence, these are essentially the ways to choose L first, and then the right end, which is then divided by 2. Ultimately, the main tactic will be essentially to find all of the LER sets that, on the contrary, do not suit us. That is to say, it will be easier to search for this, as there will be a clearer principle explaining why it does not suit us, than if we were to search for all suitable ones, which would be more in most cases. Therefore, it will be significantly easier to search for those cases in a more detailed and comprehensive manner when the result will be 0. This will only be possible in order to achieve the desired outcome if, after adding the last element of the segment, zeroing occurs. So, we have some segment with ends AL and AR, and there is some element AR1 TFSP. In the event that we subtract like this, then the sum will be, for example, less than or equal to x. Subsequently, if we add IR to this sum, it becomes greater than x. Consequently, as a result of this, the sum is zeroed. And we get 0 on this particular segment, precisely and absolutely what we want to find in this case. Yes, any number of zeroings can occur on the segment before IR. That is, the segment can be divided into blocks of such zeroings. For something we may have some whole segment again with ends AL and AR, and inside there can be several updates. One update 2 updates, and in the end, still. This segment suits us in any case because we ultimately got 0, and what happens inside is not particularly important to us. Well, rather, it will help us in solving, but for this particular segment, it doesn't matter what happens inside. At the same time, in as many partitions as the previous block participates, the current one can participate. In other words, that is, if there were some partitions involving this block, considering the scenario where a number of partitions are involved with this particular block, which ends somewhere here, which concludes at a certain point here, and it corresponds to this block and is associated with this specific block, then we can transfer all this number of ways here. Then it is possible to transfer all these numerous ways to this location. It will also be suitable. And at the same time, we will add one more. This is the count of itself, that is, the new block. Thus we obtain a subproblem, where dpi is the number of segments with the right endpoint at I, for which the result will be 0. So, what will the recurrence relation be? TFSP. Let's say we have 2 of these square blocks. Here we ended up with 0, and here we ended up with 0 for these segments, while these ends, that is the left end of this segment and the right end of this segment, are neighbors, meaning they are consecutive. So what we counted here, we pass it here and add 1, just as explained here. This will help us iterate through to determine the boundaries of the distant block for each element, and for the segment, we are specifically looking for the nearest element to the right. For example, this method ensures accuracy, such that the sum and the fat essentially equal 0. That is, in essence, we have some shark. We need to find such an AR for which the first time they will experience deflation. It can happen several times here, but the main thing, first, is to find such an AR for the sharks, so that summing all these elements in the segment results in 0. So, accordingly, where our answer will lie, it is the total number of segments that can be created here, and it's the sum of the entire DP array. That is indeed for each cell, only for this particular cell, the number of such segments will be stored, and we will save all such segments that sum to 0. Let's find their sum, and by the way, we will need to subtract a bit more. That is, from the total number of segments, this is the sum that will be subdivided. So, the idea of the solution is clear, straightforward, and easy to understand, and comprehensive. And what is happening here? If there are any questions, just to clarify, if needed. So, let's go over it again a bit more. Currently, in our possession, we have 2 blocks. These blocks are significant components, playing a vital role. Let there be an end here. And here it is G. Here will be G, plus 1. That is yes, as a matter of fact, firstly, these 2 sides consist of consecutive elements. That is, there will be some AI here, then AI plus 1, and so on. That is, it will go in order of index up to the specified. And here there will be AJ plus 1 and so on. And here there will be some AZ, for example. Is this clear? That is, the elements go in sequence here. This is a linkage. They are neighbors. And then consecutive elements occur. Is this clear? That is, everything goes in sequence here. All right. Next, the properties of these 2 blocks are that here on the segment we get 0 and only once, and here 0 only once. Before and after, we can get similar blocks, similar TFSP blowouts, and so we transfer from there to this block, to this cell in the specified, that is for DPG3 values. What was before, this will be count. In this context, as we proceed, in this particular case, plus 1, y plus 1, count is already, How many blocks are consecutive? Essentially, this counter is a tracker of how many consecutive blocks there are that yield zeros individually, and they neighbor each other like this. And this current block, count plus 1, is exactly its order among all. Thus we already get dp up to count plus 1, meaning the number of consecutive such blocks has increased. And from here, in fact, we can see the progression. We are currently already transmitting here for dpz by. Essentially, it's the same counter, but it will come from here, specifically from dpj plus 1. That is, once again, we increase the number of consecutive blocks, each of which individually gives 0 once over the entire segment. Is this clear to everyone? So, for each such element AI, it will only participate in one such block. That is, essentially, in fact, there can be some quirks here. Specifically, some block may start somewhere in the middle of this segment and end somewhere here, also in the middle of the second segment. In particular, as a matter of fact, in essence, in reality, this is how it functions. And there will already be their own coordinates of these blocks, and there it will also give 0, in fact, once in total. We will only be specifically interested in those particular cases or situations for AI that ultimately result in 0 at the end of such a block, in a manner that is satisfactory. And accordingly, this counter will show how many such blocks are consecutive, in a row, or successive, in sequence, or in succession. And so, for each such DPO, we carefully documented how many such blocks the audits participate in, which in total results in 0 at the end. And there, consecutively near 2, some blocks are not declared in detail in the process. Next, let's explore how we arrive at the final answer. To do this, we will carefully sum up all the individual elements that are part of the DPO, which we have previously identified and listed. This process. And by summing, we will find out how many subarrays can be obtained here, that ultimately yield 0 by carefully considering each element in the array. We will count all of this, sum it up, but we need the opposite situation, where there will be no 0 at the end. That is, essentially, we computed such a count, in total, subtracting all the number of segments that can be obtained here. This is simply the number of arrangements, and accordingly, minus our sum. And this will be our answer, specifically the number of ways to choose subarrays in such a way that there is no 0, because we found all the zeros using this method.
Want to become a great programmer? Subscribe to our Telegram channel.